Good afternoon and thank you for watching this video on congruent triangles. In this video I am going to give you examples on how to use congruent triangles to find the angle measures and side lengths, and how we can use congruent triangles to solve and set up equations. Now let's begin with what congruent means. Well, congruent, not just with triangles, but congruency just means that we have two objects, two shapes that are the exact same size and the exact same shape. So two identical shapes that are the exact same side. Now with triangles, there's something special and unique about triangles that isn't necessarily, well, it's true with other shapes as well, but with triangles we discuss what's called the CPCP, which means that if we have corresponding parts of a congruent triangle, then those corresponding parts are going to be congruent as well. And this is true again with other shapes as well, but we're going to be focusing on this video right here, going over only examples of triangles. Now, because triangles are so unique, and not, well, all shapes are unique in their own sense, but with triangles it's only made out of three sides and three vertices, three corners. The angles and the sides are related and congruent in the name that they are given. So for example, we see right here, we have up here that we're saying that this triangle, here's the symbol for triangle, obviously it looks like a triangle, JKL is congruent to triangle PQR. Then the name again corresponds to which sides and which angles are also going to be congruent. So corresponding parts of congruent triangles are congruent. So for example, since J is the first angle or the first corner identified, P is the corresponding part to that. So since these three sides are considered to be angles, we can name angles by the corner, by the vertice, then we know that the measurement of angle J, or let me just write angle J instead. Angle J is going to be congruent to angle P. And the same thing with K, since angle K is the middle, again the middle side or the middle vertex indicated here, then that's going to be congruent to the middle letter on the other triangle. So that's going to correspond to angle Q, and those two are going to be congruent. Angle L corresponds to angle R, and those two angles are going to be congruent. And the same thing is true about the sides. If I go from side J to corner J to K, so I have that side there, the side that uses point J to K, that's going to be congruent to the corresponding side on the other triangle, which is the first two letters of P and Q. So P, Q. Well, the side of KL is going to correspond to QR, so those two things are going to be congruent as well. And from JE to L, and let me actually draw this so we can actually see this a little bit better, okay? We have J, K, L, then the other triangle over here, let me draw it on this side, P, Q, and R is going to be located in those exact same corners as the one on this side over here. So JK corresponds to PQ, and again look at the name, it's all right there in the name. KL corresponds to QR, and JL is going to correspond to PR. So from J to L, that's going to be congruent to its corresponding part, which is P and R on the other one. So the way that the triangle itself is named, telling you that a triangle is congruent to another triangle, using the name itself, you can identify what the corresponding parts are, not just the angles, but also the sides, by where the letters are placed on the triangle. And as a result, we can write another valid congruency by the following. Like, let's say, instead of using the letters J, K, L in that order, I put K first, I put J second, and L at the very end. So basically switching just these two. Okay. Then that would be congruent again if I get the corresponding parts on the other triangle. So switching these two. So I would have that triangle KJL would be congruent to triangle QPP, not R, P R. So let's look at another example. Okay, so here we have another example. We're finding congruent angles and sides by, again, this idea that corresponding parts of congruent triangles are congruent. So by the name, I know what the corresponding parts are. Angle W corresponds to angle E, angle X corresponds to angle F, and angle Y corresponds to angle G. Side XY corresponds to side EF. Side XY, I'm sorry, I meant WX, not XY. WX corresponds to EF. Side XY corresponds to side FG. And side WY corresponds to side EG over here. So without drawing the triangle, I know what things are going to be congruent. Angle W would be congruent to angle E. Angle X would be congruent to angle F. Angle Y is going to be congruent to angle G. And then the same thing with the sides. And again, this is not only true for triangle, but any two congruent shapes. So if I get side X, WX, that's going to be congruent to the corresponding side of EF. XY is congruent to the corresponding side of FG. And WY is going to be congruent, congruent to the corresponding side EG. And another valid congruency statement, again, would be if I name the first triangle, instead of naming it WXY, I name it YWX, for example. Okay. If I name it like that, then the other triangle would have to be named G, because Y corresponds to G. W corresponds to E, so E would have to be second. And X corresponds to F, so F would have to be at the end. So, again, now this renaming another valid congruency, again, this one is a lot easier to do with triangles than it is with other shapes. With other shapes, because you have multiple sides, more than 3 sides, it makes it a little bit more difficult. You have to be a little bit more careful in the way you name them. But with triangles, because it's only the 3 sides and the 3 vertices, then you can name them in any order that you want. And as long as you, again, use and match it up with the corresponding parts, the corresponding angle, or the corresponding side, then again the congruency is going to be still valid. So let's look at an example. We are actually given a triangle right here, okay? And before we start filling in this in, again, I'm going to use the fact that I'm told how these 2 triangles are congruent. So we have that triangle XPM is congruent to triangle AYC. So angle K corresponds to A. So I'm going to use a yellow marker right there for this angle in that angle. So those 2 angles are congruent. So they're equal to the exact same angle measurements. P corresponds to Y, so I'm going to put P and Y have the same angle measurement, and M corresponds to C, so C and M are the same angle measurement, which means again that from C to P, which is K to P, this one right here, let me mark it with blue and also a little line right there, is going to be congruent to the corresponding side from A to Y. So from A to Y, I'm going to color it the same color, blue, and I'm going to put again that one little marker there. Well, PM from P to M, which is this side down here, the second and third letter in the name of our triangle on the right, on the left, on this triangle on the left, is going to be again congruent with the corresponding side of YC. So from Y to C, those two angles are going to be the same. Now it's easy to indicate again that they're the same by using different colors, but if I don't have different colors, then what I use is a little marker, like a little tally, and since this is the second side that I'm using or indicating are congruent, I'm going to put a little tally mark of that there. So those two sides are equal to each other. And then finally, from K to M, this side right there, this side of KM, which I'll use the color green. So right, that one out the third side, so I'm going to use 3 little marks right there. That is going to corresponding to from going from the first letter to the last letter, AC. So from A to C, which is that side right there. So you see, those are going to be the corresponding sides. And again, I really don't need the shape. I could just again look at the name itself, and using the name, no need of this right here, I can identify and answer every single one of these and identify which is going to be the congruent side or the congruent angle to the given one. So from KM, since it uses the first and the last one, okay, which is this green one right here, let me get different indicator. Let me use this yellow indicator. So this green one right there, well, using the first and third letter means I would have to use the first and third letter over here. So that's going to be AC. So segment AC. And again, as you can see, that's what I marked. I marked that A to C, which is this diagonal line here, is also green, because again, they're going to be congruent. So CY is the same thing as PM. So C to Y, the same thing as P to M. P to K, P to K is this angle right here in blue. So it's going to be the blue one on the other triangle. So that's A to Y. And if you name it Y to A, that's the same thing. I know over here we're using the name PK uses the middle one, and the second one. So it's P and then K. So you can use Y and A, or you can just simply say AY, as long as you're still using again the first and second letter on the name of the triangle, just like the way you're using over here. The order doesn't matter as long as you're using again the corresponding sides. So in this case, KP is the same thing as PK, just like AY is the same thing as YA. Now with the angles, well, it's only one letter, so you have to name the correct angle. So angle Y, which is the second letter on this triangle, would be corresponding to the second letter on the other triangle. So that would be corresponding to angle P. And let me put my little congruency symbols up there, which I didn't do that over here. I should have written again that these are segments. So I'm saying that the segments are congruent to each other. So let me go back and fix that. because without that, I'm really trying to identify that the links, that the segments are equal, meaning that they're the same length. Here I'm trying to indicate that segments are congruent, so I have to indicate that properly by using that symbol there. But if you didn't, again, I'm not gonna be too picky, and if you write that like on your homework or something like that, I'm not gonna be too picky and like mark it wrong just because you didn't write this same notation on top. Now for angle K corresponds to angle A. I'm going to move to G before I go to F. Well, I might as well start there. Angle ACY is basically again angle C, because angle ACY starts with A, goes to C, and then goes to Y. Remember that another way of naming an angle is by simply using the middle points, just simply using the vertice, which in this case the vertice is C. So angle C corresponds to angle M on the other triangle. So this is going to be congruent to angle M. If we want to use the three letters, well, again, just use the three letters in the same order as the way we're using them here. So angle A corresponds to angle K, angle C corresponds to angle M, and angle Y corresponds to angle P. So this angle from point A to C to Y is going to be the same thing as going from K to M to P, which again, as you can see, is that color right there, the green angle right there. So it's the same thing. Now they want the triangle. Well, this one you have to use the three letters. You didn't have to use the three letters down here. I could have just said angle M again and it'd been fine. But over here you want to use the three letters, and because again we're trying to name the actual triangle. So the triangle is named MPK. Well, MPK would correspond to C, P would correspond to Y, and K will correspond to A. Sorry, got lost a little there. And triangle WAC, YAC, will correspond to P, A corresponds to K, and the C corresponds to M, to PKM. So triangle PKM is congruent to triangle WAC. And like I said, you really don't need this again if they already gave you the name. Just with the name, I don't need to draw myself this. I can just simply use the name and see where the letters are placed and know that those corresponding sides or angles are going to be congruent to each other. So like right here, again, I'm going to fill in the space. I'm going to fill in the parts that I have here. I'm going to fill in the parts that I'm missing on this triangle, and the same thing on this triangle, knowing that these two triangles are congruent. So let's start off with the angles first. Angle S corresponds to B. So let me use highlighted. So angle S corresponds to B. So S and B. T corresponds to F. So T and F. And W corresponds to N. So W and N. And now we have the sides. So ST, which is this one right here from S to T, which uses the first two letters, would be the corresponding side to BF, which uses again the first two letters on the other triangle, BF. So again, ST. Let me use the darker one. Let me use the red one. And so S to T, B to F. T to W. So from the second to the third, T to W. T to W, which is this top angle right here. Let me get a thicker pen. Let me use that one. There we go, so it can stand out. T to W. would correspond to Fn. Again, second 2, second 2. And then the last side, well, obviously the remaining side, which is Ws. Again, let me pick a thicker color pen. W to S, which is the first and third letter, would have to correspond to, again, the remaining angle over here, or the remaining side over here, which is B to N, which uses also the first and third letter. So let's see, let's fill things in, okay? So the green side, which is 9 centimeters on this triangle, would have to be the same as that one. So this one is also going to be 9 centimeters. Since this side right here is 14, again, which is in red, that means that the red on the other triangle is also going to be 14. And the same with the blues. The blues are also going to measure the same length. So this one is also going to be 17. The yellow angles measure the same thing. So this angle S corresponds to this angle B. They're congruent. So this is going to be 67 degrees. And the same thing with the green one. So if this angle N is 82, then that means on W, those again are also going to be the same. So this is going to be 82. And the only thing that's missing is going to be, again, this top angle, again, which I've highlighted in blue, the F and the T. And the way I'm going to figure that one out, we're using, again, our angle sum theorem, that the interior angles adds up to 180 degrees. I will simply get 180 degrees and subtract the 82 and the 67 to figure out what the measurement of this angle up there is. So subtracting 82 and 67 is the same thing as subtracting 149, which is equal to 31 degrees. So this angle measurement is 31, which means this one is also going to be 31, because again, they are congruent. And then we can fill in, again, we can fill in all of this. Now that I have all of this filled out, I can fill in this and find the missing angles and side lengths. So from B to N, as you see, that's over here. That's the one in red. That's 9 centimeters. From T to W, that's equal to 14 centimeters. Again, here it is, T to W. From B to F, that's going to be 17 centimeters. And now for the angles, angle W is equal to 82. Angle angle B is equal to 67, again, degrees. And then finally, angle F is going to equal to 31. So voila. Let's see, let's move on to another example on solving equations with congruent triangles. Okay, so again, I'm going to just simply use the names, use the fact, and instead of, again, since you might not have, again, all these different colors or might not have various highlighters or things like that, let me show you a different way with it, just using one color. So we know that the angles are going to be the same because, again, of the way that they're laced, and the same thing with the corresponding sides. So starting with the angles, U corresponds to T. So I'm going to use this type of indication now. So U and T are congruent. So I'm going to use that to indicate that. V and S are congruent. So to indicate that V and S are congruent, I'm going to use the same indication, but now I'm going to put a little different mark. I'm going to put a little mark right there. Okay, so those two are going to be equal to each other. W and R are going to be congruent, so I'm going to use the same same little, again, little semicircle, angle, little, again, curve, but I'm going to use a different marker. So I'm going to use like a little X there to indicate that, okay, all right, those two are congruent. And the same thing with the sides. From U to V, the first to second letter is congruent to S to T, T to S. So from U to V, I'm going to indicate by putting just one mark. T to S, putting one mark. V to W, I'm going to put 2 marks. And S to R. So S to R, I'm going to put 2 marks. And then obviously the last one are going to be congruent. So those 3 are going to be congruent. So U to W, which is this one right here, as you see, is congruent to T to S, as you see those right there. So you see the name tells me again how these things are congruent. So even though they're not in the same direction, I'm just using the name because again, corresponding parts of congruent triangles are congruent. So with that, I can figure out the value of X, Y, and Z. So let's start off with X. I see X is right here. So what is 12x minus 7 going to equal to? Well, looking at this triangle, since this is marked with 1, that corresponds to this one as I marked prior, which is equal to 53. So solving this equation, I would add the 7 to this side, giving me 60, bringing down the 12x, equal to 60. I divide by 12, and x is going to equal to 5. Now to figure out the value of y, let's see where y is. Here's y. So 5y minus 33, what is that going to equal to? Well, since this one is marked with 2 marks, I'm going to look over here on the other triangle and find the one that I've marked with 2 marks, which is 57. So 5y minus 33 is equal to 57. So with the whole letters to the left, numbers to the right, I'm going to move the 33 to the right side, and 5y is going to equal to 90. I'm going to divide by 5, and I'm going to get, I believe this is 16, yes, 16, no, 18, yes, y is equal to 18. And lastly, the only one left is going to be z. Well, where is z? Here's z. 3z plus 14, well, again, with the 3 markers, that's going to correspond with, on the other triangle, the side that has the 3 marks, which is 50. So 3z plus 14 is equal to 50. So subtracting 14 from, moving the 14 to the other side and subtracting it, I get that 3z is going to equal to 36, and dividing the 36 by the 3, the value in front of the z, I get that x is, I'm sorry, z, wrong letter, wrong variable, z is equal to 12. So there are the values of my 3 variables. X is equal to 5, y is equal to 18, and z is going to equal to 12. Now in this example, I kind of wasted my time focusing on the angles. The angles were really not helpful because none of the angles were marked. The only thing that were marked were the 3 sides. So I really did not need to do that. On the next example, example number 6, the angles are what are now measured. Okay, those are the things that are now measured. So this one's going to require again to me labeling them. So let me again use a way again with the same color, show you how to indicate, how to mark them, just in case you don't have again various highlighters. So here P, so let me just mark it with that. P is going to correspond to C. Alright, so those 2 things are going to be equal to each other. So this is going to equal to 36. So I could set up that equation. 4z minus 32 is equal to 36. H is going to correspond to n. So H and n are congruent. So I'm going to use this with a little marker and indicate this one with the same little marker. So those 2 are equal to each other. So 6x minus 26 is equal to 115. And the only one that's missing again is going to be the other variable. So we want to again solve this equation for x, y, and z. And you know what? Let me just do that. Okay, I'm just kind of wasting my time here trying to label them first and then solve. So let me just set up, and let's start off with x. Okay, so here's x. X is on angle h. Angle h is the second letter on the triangle on the right, so that means using the second angle on the triangle on the left, using the second angle on the right one, and I know that those two sides are going to equal to each other. So if I set 6x minus 29, that's going to equal to 115. So adding 29 to both sides, I get that 6x is going to equal to 4. 6x equals to, that's going to be 14. 144. I'm going to divide by 6. And that's equal to 24. Yep. So I get 24. So I got the value of x now. Let's now look at the value of y. Let's see. Angle y is up here. That's on angle f. Angle f is the third letter on the name right here. So that's going to correspond to s. The third, again, the corresponding part is s. So those are going to be congruent. Well, we don't have an angle measurement right here, so we have to figure that out. Well, I know that this one is 39, and I know that from what I just solved that n and h are congruent. So I know this angle measurement has to be 115. So this one right here is equal to 115. Again, that's why I put these two things equal to each other, because again I know that they're equal. So I can ignore this, and let me actually ignore it. Let me ignore this completely, and let's focus on the idea that instead that this angle right here is going to measure 115. So if this is 36 and this is 115, I can figure out the measurement of this angle by again using the triangle sum theorem, that the three angles have to add up to 180 degrees. So I get 180 degrees, take away the 36, and take away the 115, I can figure out what this missing angle is there. So taking away 115 and 36 is the same thing as taking away 151. Yep, 151, because 115 plus 36 is 151. So taking away 115 and 36 is the same thing as taking away 151 from 180, and we're going to get with 29. So this angle measurement is going to equal to 29. So now we can figure out the value of y. So this one took a little work to set up our equation, because we didn't know what this angle measurement was, but we knew that these two angles were again 36 and 15. So now we can set up our angle. We can set up our equation, I'm sorry. So angle F is going to correspond to angle S, which we now know is 29. So getting 3y minus 1 and setting it equal to 29, we add the 1 to this side, and 3y is equal to 30. We divide by 3, and the value of y is going to equal to 10. And the only one that's left is z. So 4z minus 32, what is that going to equal to? Well, angle C, which is this angle right there, corresponds to angle P. And we know that P is 36. So we set that equal to 36. So moving this to the other side, that makes it positive 32. And 4z is equal to 68. And I divide that by 4. That's going to be 17. So z is equal to 17. And there, we found the angle measurements, all three of them. So this one was a little bit tougher because we had to do, again, figure out what this missing angle, but we had enough information to figure that out. So we can set the 29 equal to the 3y minus 1. So let's see. Let's look at another example. I'm missing an example right there. So let's move on to example 7. Here it is, example 7. So in example 7, I'm not given again an actual shape. I'm just given again the names of these things and see what things are congruent. If you want to draw yourself two congruent triangles, you can. So let me do that for us. Here in our example, we have, that does not look like a triangle. There we go. So we have this triangle there. I'm going to draw the corresponding triangle, the congruent triangle to the right of that. And because of the way it's named, DEF, if I label it D, E, and F in that order, on this second triangle, I have to label the letters J, K, L in the same order. So I have to start on the bottom left, go to the top, put K, and L would have to be on the right. So left, top, and right, just like I did this one. Left, top, and right. So I know that DE, which is 18, is going to correspond to JK. So DE is going to correspond to JK, which they tell me here it is. JK is 3y minus 21. I know that from E to F, which is 23, is going to correspond from K to L. And do they tell me K to L? No, I have no information about K to L. No information at all about K to L. And I know that from D to F, they do tell me about D to F. D to F is 9x minus 23. That's going to correspond, let me put a marker with 3. That's going to be congruent to the corresponding side of J to L, that bottom side right there. With JL, that's 7x minus 11. So this is equal to that, and this bottom side is going to equal to that bottom side right there. So let's start off with the x's. So 9x minus 23 is going to equal to 7x minus 11. So now with letters to the left and numbers to the right, I would subtract 7x and I would put plus 23 on the right. So we would end up with 2x and negative 11 plus 23, that's equal to 12, and dividing by 2, x is equal to 6. Now for the y, well, this has the y, and that's going to equal to 18. So 3y, not 2y, I'm sorry, 3y minus 21 is equal to 18. So this equation is a lot easier to solve. We're just going to simply add the 21 to the right side. We're going to get a total of 39, and dividing by 3, y is going to equal to 13. So those are the values of both x and y, which is what they wanted us to do. They find out the value of x and y. Now example number 8. Again, they are not providing a triangle for us, so let's draw ourselves our own triangle. So we have that triangle there, and our congruent triangle to the right. I'm going to label them the same way I did the previous one. I'm going to start with on the left, go to the top, and then go to the right, again in the order that the name is. So QRS, and then for the one on the right, using the letters M, N, and P, I'm going to start at the right, on the left, left, go to the top, and then go to the right. So M, N, P. So it's easy again to indicate again what the corresponding sides are. So we have QR corresponds to the left side on the other triangle. So well, QR is 11, Do we know what the measurement of MN is? No, we do not. We don't have anything about that. QS, which is this bottom one, that is 15. And I kind of already labeled them. I kind of got ahead of myself, didn't explain what I was doing. SR corresponds to NP, so that's indicated again with 2 markers. And the last letter, QS, which is the bottom one, corresponds to M and P, which again is the bottom one, so indicated with 3 markers. We're told that QR is 11, QS is 15, indicated as that. MP is 2x plus 1, so MP is 2x plus 1. Angle S is 84 degrees, so this angle right there is 84 degrees. Angle R is 32, so angle R is 32. And angle M is 17y minus 4. So that angle right there is 17y minus 4. So we can figure out the value of x because again these two sides are congruent, they're equal to each other. So 2x plus 1 is equal to 15. So moving the 1 to the other side, that would subtract it, and 2x would equal to 14. We divide by 2, and x is equal to 7. Now remember, again, opposite side, opposite sign. I haven't been emphasizing on that on any of these last videos, because again, we've been solving equations for a while, but you need to remember, again, we still make sometimes, I've been noticing in your work, that we make that mistake and forget to, again, when we move the 1, that we're essentially subtracting 1 from both sides. But since we're sticking to the idea of letters to the left, numbers to the right, again, to simplify this concept, we forget that we should be writing a minus 1 right there. So 15 minus 1 is 14, and then dividing it by 2 is 7. Now, for the y, to figure out the value of y, since we're looking for both x and y, this is where the y term is. That's going to correspond again to this angle right there. The 17y minus 1 again corresponds to the angle M, which corresponds to this angle right there, but we don't know what the measurement of this angle is. We don't have a numerical value nor an expression, but we do know that the top angle and this right angle here are 84 and 32. So we can figure out the missing one by again using the triangle sum theorem, that these 3 angles again add up to 180 degrees. So if I get 180 degrees and I subtract 84 and 32, which is the same thing as subtracting 6, 8, 9, 10, 11, 116, I can figure out the measurement of that missing angle. So 180 minus 116 is equal to 64. So the measurement of this angle here is equal to 64. So that means that this and this are going to be congruent. So 17y minus 4 is equal to 64. So I'm going to add the 4 to the 64. Since I'm subtracting on the left side of the equation, that's going to equal to 68. And since I'm multiplying by the y by 17, I'm going to divide by 17. And that's going to equal to 4. So there, that's how we figure out the value of x and the value of y. Alright, so that concludes again the examples on how to use congruent triangles to set up equations and find missing angles like we did in the prior examples. So we can set up equations again because corresponding parts on congruent triangles are congruent. So we're going to identify again what the corresponding parts are so we can set them equal to each other, again have them be congruent, and we end up again setting up an equation, solving for my variables, or like we did in these first examples and examples 3 and 4, figuring out what the angle measurement are, or figuring out what side is going to be congruent to the other triangle. But again, we really don't need the actual shape. Okay, having a shape can help, but it's not necessary, because the name of the triangle being congruent to another triangle with three sides are going to tell us again what the corresponding parts are, and thus we know what's going to be congruent. Well, again, thank you for watching. I hope this was again helpful and clear. And again, if you haven't subscribed to my YouTube channel, please do so. You get notifications on when I upload the next videos. Like I said. So y'all have a wonderful day, and I'll see you next time. Goodbye.